Students, here we come for the problems. Figure depicts a racing track whose left and right ends are semicircular. So this end and this end are semicircular. Let me join this so we can call it as a diameter and it's semicircular. So distance between the two inner parallel line segment is 60. So this distance is they said as 60 meter. So it's parallel. So everywhere it's a 60 meter. And they are each 106 meter long. So this parallel length is 106 meter long. This is also 106 meter long. If the track is 10 meter width, this width is a 10 meter. So here is also 10 meter, here is also 10 meter, here is also 10 meter. Width, find the distance around the track along its inner edge. So inner edge, we have to find this region. So we call it as a this two region we call it as a circumference of this semicircle and circumference of this semicircle, and this length just we can add two parallel lines, right? So for that we need this is, we know this is a 60, so diameter is equal to 60 meter and radius will be the 30 meter and the parallel length is 106. So first thing is we have to find the distance, right? Distance along inner side of track is equal to, the first is that we can add the perimeter of two semicircle, that is circumference of two semicircle, plus this two distance parallel lines, right? So length of two parallel lines. So this is a semicircle, right? So two semicircles, 2 into semi means half of the circle is circumference is 2 pi r, plus this two length is 106 plus 106. So here 2 get cancelled, balance 2 into 22 by 7 into r is a 30 plus 106 plus 106 212, and this nothing is going to cancel. 2 into 22 4 into 30 is a 1320 plus 7, so divided by 7 plus 212. So let you take an LCM, it will get 1320 plus 1484 divided by 7, which is equal to 2804 by 7 meter. So this is the length distance around the track at the inner edge. So next, the area of the track, we have to find this total area, the shared area. So you can see that this is like a rectangular shape, so there will be two rectangles are there, and this is like an from the bigger circle, the smaller circle you have to subtract. We call it as a concentric circle with the same center, right? We call it as a concentric circle. So area of the two rectangle plus area of the two concentric circle, right? So second one is area of track is equal to area of two concentric circle plus area of two rectangle. So 2 into concentric, is it circle or semicircle? 2 semicircle, right? 2 concentric semicircle. So 2 into half into area is a pi, concentric circle is a pi r1 square minus r2 square, right? That's a concentric circle formula. And area of two rectangles, 2 into L into B. So we know that this length is 106 and breadth is given as a 10 meter, and here this radius, the one is 30 and the bigger one is, we have to add this 10, it will become a 40, right? So 2 get cancels, 22 by 7 into, or so 40 square minus 30 square plus 2 into, here length is 106 into the breadth that given with is a 10. So 22 by 7 into 1600 minus 900 plus 2 into 1060. So we have to subtract here 22 by 7 into its differences are 700 plus if you multiple we will be getting as a 1120. So 700 for 100 times, so 2200 plus 2120. So what is the difference? Sorry, we have to add here, right? So if we add, we will be getting a 4320 meters square. So that is the area of the track. So while finding the area of the track, this you consider this as a two rectangle and this as the area of concentric circle. So here we go for the next problem. In figure A, B and CD. AB and CD are the two diameters of the circle with center O and perpendicular to each other. So this is a perpendicular to each other, so it is like a four quadrant. And OD is the diameter of the smaller circle, so this will be the diameter for the smaller circle. If OA is 7 centimeter, find the area of the shaded region. So this is 7 centimeter, this smaller circle diameter is also 7 centimeter, right? Smaller circle diameter is 7 centimeter and radius is equal to 7 by 2 centimeter. And what about the big circle? The big circle radius is a 7 centimeter, right? So radius is equal to 7 centimeter. And next we have to find the shaded region. So this we can find the area of the circle. What about this shape? We can find the area of the segment, or else another way is that just consider this semicircle. You can see in this semicircle this triangle is removed. We already know in the semicircle if the two line is joining this diameter, this will be a perpendicular, right? And also we know that one more is here is the perpendicular, so we can consider this as the base. So 7 plus 7, so the triangle, so base is equal to 7 plus 7, 14 centimeter, and height, this is the same radius, 7 centimeter. So we can find this area of this circle plus area of the semicircle minus this triangle, right? So area of shaded region is equal to first area of the small circle, area of small circle plus here we are doing the two process, area of big semicircle. With that we are going to minus the area of this triangle, area of triangle. So area of the small circle, and here we have to differentiate the both r, right? So let me do it as 1 and 2. So area of the small circle is pi, the small circle is r1, pi r1 square plus, so area of the big circle is, and it's a semicircle, right? So half into pi r2 square minus area of the triangle, it's half into base into height. So the pi is 22 by 7, r1 square is 7 by 2 here, 7 by 2 into 7 by 2 plus here half into 22 by 7 into here r2 is 7 into 7 minus half into base is 14 and it is 7, 14 into 7. So 7 cancel, it is 11 times 1 times 7 times, right? So here 11 into 7 is 77 and denominator 2 is that, plus here denominator nothing is there, 11 into 7 is 77 minus here 7 7s of 49, right? So 77 by 2 plus 77 minus 49 is a 28. So let we take an LCM. So 77 plus 56 by 2, that is 2 is multiplied here. So 77 plus 56 is 133 by 2 into, we can easily divide half is a 66.5 centimeter square is the area of the shaded region. So here we found this area of this full circle plus area of this semicircle minus the triangle, you will get the shaded region. Clear? Even you can try with this like in a segment, but it will go a little longer. We need the triangle and we have to find. Even you can try that, or else you can use this. So here we come for the final problem. The area of equilateral triangle ABC is given 17,322.5 centimeter square. With each vertices of triangle as a center, a circle is drawn. So from this, the circle is drawn here, and from the B there is drawn, and from the C there is drawn. So it is given an equilateral triangle, so this will be 60 degree, 60 degree, and this also will be 60 degree. This circle is drawn with the radius equal to half the length of the sides of the triangle. So if we know the sides, this radius is half of the sides. So side is not given, only the area is given. So from this area we can find the sides, not a problem. Then we can find the radius also. So find the area of the shaded region. We have to find this area of the shaded region. So if you find the area of the triangle is given, then with the area of the triangle we have to cut this surface. So it is like in a sector, right? So this 3 sector we have to cut, and we have an angle theta, but we need a radius. To find the radius that is given, this half of the sides of the triangle, we have to find the sides of the triangle. So area of equilateral triangle is given as a 17,320.5. They said to use the value pi is equal to 3.14 and square root of 3 is equal to 1.73205. So area of the equilateral triangle, we know that square root of 3 by 4 into side just representing as a square, and let me take this side, we will get an a. So a square is equal to 17,320.5 into 4 divided by square root of 3. So instead of square root of 3 we can substitute this value. So a square is equal to 17,320.5 into 4 divided by 1.73205. And this and this are same, right? Just only that decimal is misplaced. 4 digits, right? Then it is for a 10,000 times. So a square is equal to 10,000 into 4. So a square is equal to 40,000. Then a will be 200, right? So taking the square root, we will get a as a 200. So a is the side of the triangle. So side is equal to 200. Is it centimeter? Yes, it's centimeter, right? Centimeter. So radius is said it's just half, right? Then radius will be 100 centimeter. Now we can find the area of the shaded region. Area of shaded region is equal to, from this area of this triangle we are subtracting the 3 sector. Area of triangle directly given minus area of 3 sector. So area of the triangle is given as 17,320.5 minus 3 sector, right? So 3 into theta by 360, theta is a 60 degree, 60 degree by 360 into pi value they said to use a 3.14 into r square. So r is a 100 square, 100 into 100, right? So what are the possible things? We can cancel 6 times 2 times, there will be here, let me cancel this, 1.57. So 1.57 100 into 100, so 1 little decimal will go, then 15,700. So 17,320.5 minus 15,700. So if we subtract, we will be getting as a 1,620.5 centimeter square. That's yes. So here it is given as equilateral triangle and the area is given. So from the area we have found the side and they said radius is half of the side. So after finding that, we found by the area of the triangle minus area of the 3 quadrant. Thank you.